All right, so in this video, we're going to go through sample question 68 from the Society of Actuaries, ExamP, list of sample questions. The question reads, an insurance policy reimburses dental expense X up to a maximum benefit of 250. The probability density function for X is the following, right there. So, we need to calculate the median benefit for this policy. So once again, this is a situation of we're given some sort of expense or loss, and then a policy that's got a limit / deductible, in this case a max limit of 250, and something I don't remember seeing for a little bit, calculating a median. All right, first things first. Our density function's got a constant up front, C. We have to figure out what that constant is. Now, in order to figure that out, if you integrate a continuous random variable over all of its, over the entire domain, it should equal 1, right? That is a standard rule within probability. So 1 should be equal to the integral from 0 to infinity of C e to the negative 0.004 x dx. All right, and all in all, this is not a tricky integration. I'm going to take this constant out, so 1 is equal to c, and then integral from 0 to infinity e to the negative 0.004 x dx. And I say this is super easy because I noticed something, just kind of a quick trick to doing the integral of any e to something. All it's going to be is the inverse of the coefficient of x multiplied by your original thing. Meaning this is going to be 1 equals c multiplied by the inverse of this, which is 1 divided by negative 0.004, negative 250, multiplied by e raised to, it's all the original thing, 0.004 x, and then I'm evaluating that from 0 to infinity. Okay? And that's just a quick trick. I'm sure other people use it a bunch to integrate really quickly in e to the something x without having to do u substitution. Okay? This can be real quickly evaluated because if we notice, if you plug in infinity for x, plug in, you're going to do your normal thing to figure that out. It's going to tend towards 0. Plugging in 0, this thing becomes e to the 0 power, which is just 1. So this ends up being c times positive 250. And then I can divide on both sides. And actually that happens to be 0.004 is equal to c. Neat. Okay, so plugging in 0.004, we get the following. F of x is equal to 0.004 multiplied by e to the negative 0.004 x. And this is where it's really useful to memorize rules about probability distributions, because that is an exponential distribution, right? That is very clearly an exponential distribution, which will help us out tons. So here's where it's going to help us out. We're asked to find the median for the benefit of the policy, right? The median is anytime your cumulative distribution is equal to 0.5. That value, whatever makes it that, is your median. And the exponential distribution is really nice because we got a clean formula for the CDF. And that happens to be 1 minus e to the negative x over theta, where theta is your expected value. In this case, this thing up here is equal to 1 over theta. So theta would be 200, right? And that's equal to your CDF. So what makes our loss 0.5? Let's take a look. 0.5 is equal to 1 minus e to the negative x over, just double checking, yeah, that is 250. And okay. And I'm just going to solve. So I'm going to move this over to the other side, get rid of the negative sign. This will just become 0.5 is equal to e to the negative x over 250. I take the natural log to both sides, right? Yeah, it looks fine. Natural log to both sides. And I get ln of 0.5 is equal to negative x over 250. And multiply 250 to both sides and throw a negative up front. So this becomes negative 250 natural logarithm 0.5. Okay, and that's equal to whatever x is. Let's see. Okay, and then we find x is equal to 173.28 7. Okay, that's our loss. Now, here's the thing. That loss never actually hits our max benefit. So that's not even something we really need to consider in this case. The median payment is the median loss because the benefit is never taken into consideration. We never actually hit the max. So we just result with answer choice C. Okay, so just a quick overview of this problem. It gives us a density function, right, with some constant out front, and that's not unusual. Sometimes a question will frame will frame a situation of here's a density function, or the density function of a random variable is proportional to this equation, where essentially it's that equation and a constant in front is the density function. So having to solve for this constant is something you're going to need to know how to do. It comes up. The way you do it is understand, okay, if I have a continuous random variable, I integrate over the entire space, and I solve for that constant, and I then plug it into the original density function. I'll get what the actual density function is. And then from this, it goes kind of separate from what those other questions might do. It's super important to recognize this is exponential. It makes your life so much easier because for this question, a median is the value that causes your CDF to be equal to 0.5. Since we have a really nice formula for CDF, I'm able to solve for what value of x causes this to be 0.5, and I found it to be 173. And from there, I just have my answer. That is my median benefit. And that's pretty much it. If you have any questions, anything you want me to clarify, throw it down in the comments. I'll answer it to the best of my abilities. If you want to see more problems like this, I've got a playlist, sample questions. on the Society of Actuaries ExamP stuff. If this video helped you out, hit the like button and subscribe, because that totally helps me out. And other than that, good luck.